Okay, welcome to our new chapter. We are officially in chapter 3. Chapter 3's topic is, you can't really see it here. Chapter 3's topic is called polynomials. Polynomial functions. So we're moving from quadratic functions to a new type of function. And the first thing we're going to look at today is what graphs of polynomials look like. And we're going to look for some patterns. So these are some examples of polynomials. What you'll see is polynomials involve having x raised to powers bigger than 2, or including 2, excuse me. So a quadratic function is kind of in the family of polynomials, so to speak. So we look at powers of like 1, 3, 5, 7. If you look at the odd powers, we look at how 2, 4, 6, and 8 compare. So the way to think about it is, if we think about it kind of pictorially, inside polynomials, quadratics are a subgroup. And it's raising x to some power, right? The power could be 1, 2, 3, 4, 5. Notice we're doing whole numbers. And we're going to look at some of the patterns with what these graphs look like. So I've got odd powers, even powers, odd powers with a negative sign in front, and even powers with a negative sign in front. So we're going to see if there are any patterns that emerge. Okay. And in your notes, if you could make a similar table as this, just something in your notebook, or if you've printed it, you've got a copy. And we're just going to look at the first grouping. So I've got x2, if you think about it as the first power, right? Third, fifth, and seventh. And so I'm going to turn them on and off so we can see them one at a time. So x to the first power is like the line y equals x. When I cube, notice there's a change that goes on there. And then there's fifth, and I'll kind of zoom in so you can see it a little bit better. So that's third compared to fifth, and then I'm going to turn this one on, but I'm going to make it a different color. I'm going to make it purple just for some variety. So notice how the purple, the black, and the green compare. So green to black to purple, right? You'll notice all of these graphs have a similar shape, right? So in my notebook, I'm going to go ahead and add that observation is they kind of have a shape that looks like you go up on the right side and down on the left side, right? The middle has some changes. Oops, it's not a great arrow, but you generally go up on the right, right? And you generally kind of go down on the left. And what's interesting to look at is how the 3, 5, 7 are changing. Notice as my exponent gets bigger, it gets closer to the axis. So it kind of hugs it even more tightly as we increase. You can kind of see it really nicely here of the third, fifth, seventh. If I make it like the ninth power, right, it gets closer and closer just to kind of show that pattern. Okay, the next one we're going to do is the odd powers, but with a negative sign in front. So slight tweak. I'm going to turn these off, and we're going to look at it to the first power, right, to the third, to the fifth, and to the seventh. And I'm just going to change this to a different color just for some variety. Notice we've done a reflection, right? What used to be up got reflected down across your x-axis. What used to be down got reflected up. So in my notes, I'm going to make a note that my general shape kind of looks like up on this side, something's going on, and down on this side. So down to the right and up to the left. Sorry about that. It's doing that even on my day off. Hope you guys are having a good, or hope you guys had a good Veterans Day, by the way. That's when I'm recording this lesson. And then we're looking at evens, right? So let's check evens. So we've got second, fourth, sixth, and eighth. And these are really interesting to look at as well, right? Notice, similarly, as you go to bigger powers, it kind of hugs and gets closer to that axis, right? If we kind of zoom in, oops, wrong way. If we kind of zoom in, you can really see that nicely. And it starts kind of forming less of a bounce, like a parabola, and it gets more and more like a U almost. So in our notebooks, we're going to put like a general rule, is that it's up, and then something happens in between, right? It might be more of a U, it might be more of a parabola shape. So it's up and up, right? Both facing up. A lot of times when we're practicing in class, we practice with our arms and we kind of show facing up, facing down, right hand up, left hand down versus left up and right down. That's a really nice way to bring movement into the learning. And then we've got the same one but with negatives. So squared, fourth, sixth, and eighth. And you'll see it's just been reflected across the x-axis, right, with that negative coefficient. So we're seeing the same sorts of patterns just facing downwards. So I'll put that here. And it's down and down. Notice that that squiggle, right, it's referring to sometimes it's more clean, sometimes it's tighter, right? There was some variety in all of these, how they are behaving in between, but generally it's going down and down is kind of the big idea. Okay, and then I have a question at the bottom, what are you wondering? Is there anything you're thinking about? This is a good spot to write down any questions or ponderings you're having right now. Write some stuff down, and then when we talk together on Tuesday, that'll be a good time to bring up some questions and talk about what things were we curious about, what things did we want to know more about. So we'll try and carve out some time to share these on Tuesday. Okay, that's a really messy Tuesday. I promise it was supposed to be Tuesday. It's kind of a Tuesday, there we go. So we'll share those on Tuesday. So here is the formal definition of a polynomial, right? We've seen examples of them, right? Remember, quadratics are a subset of a polynomial. So the top of the page, feel free to pause and write this in your notebook, right? This top part here is very much like what you'll see in a textbook. It'll give you something of this nature, and they'll talk about how you've got coefficients, like A and B are coefficients, C is a constant, and those are, nice whole numbers, or real numbers, excuse me. They might be, a half, but real just means not imaginary. They just mean it's a normal real number, right? Not imaginary. That means they could be fractions, could be like a half, whereas the exponents are always whole numbers. The one thing that some students find a little weird is this notation here. What that's referring to is that the previous exponent, like if I'm to the nth power, I kind of go in order biggest to smallest, and then I go like a power smaller. So generally, that's kind of like if I look at this example down here, I've got some examples of what they might look like. We've got second power followed by first power. So that's kind of referring to what's going on here with the purple. And thinking about like something like a constant like 3, that's like x to the 0, because anything to the 0 is like 1. So that's why that one doesn't have an x. So we generally write it biggest power to smallest, right? Sometimes we don't go straight through, right? This one goes 7 to 2 to 1. That's totally fine. So you just go in order. This also encompasses linear functions, right? So linear functions, let's add that to our kind of thought process. There's also linear, right? Like graphing lines. You guys saw lines in Algebra 1. That was the main function you guys explored there. And we did see those in Chapter 1 as well a bit, especially with our piecewise functions, right? Pieces and lines put together. So it could be a line. And it also could be a constant function, right? This is just where you can visualize this one, is you have a 0 in front of like x to the 3rd power and a 0 in front of x squared, right? Everything gets taken away except for that constant you have at the end. So lines, like h of x and j of x, lines are also part of polynomials. And then there's one other big idea. It's called the leading term. The leading term, I'm going to do it in green. Leading term is the first term. So it's like this whole thing. oops, sorry, I thought that was two separate functions. So first term, right? It's always your first term. It's got your highest power, right? Your leading coefficient, if I'm looking at an example, if I look at 5x to the 7th, the whole thing is the term, right? Your leading coefficient is the number in front, and the degree, I'm just going to use some color coding, is the power. So just to give an example of what those vocab words are, because we're going to use them, and it's just to have a common vocabulary to talk about these functions. Okay, this end behavior, the end behavior of the function, right, that we saw here, like the shape of what it looks like, that's determined by the leading term. So for instance, if I go back to Desmos, right, we focused solely on looking at functions that were just like x to the first, y cubed. But what I could do, right, is it could be x to the 5th, maybe plus 5x cubed, right? It matters that the biggest power is the 5th power. That means that it's in this grouping, right? Could be plus 2x minus 1. Oops. Plus 2x minus 1. There we go. And that one looks like a little bit weird, so I'm going to maybe take that out because it doesn't look quite as nice. So here's an example, and it's just been shifted down, as you can see. But this graph also has that same end behavior of up to the right, down to the left. Notice it is in that category as long as its highest power is an odd power, right? The highest power is a 5. So our end behavior is what we're describing by that. Right? These observations are end behavior. So if you have an even power, that's your leading term, right? If the highest power is even, and if it has a positive a, that could be like something like, I'm going to pause and give some examples of what these functions could look like. Okay, so here are some examples of what these might look like. Notice like even is referring to the biggest power. Biggest power is an even exponent. Right? Whereas odd, an odd is referring to, oh, did I make them, dear, that one should be like a 7. I'm going to make it a 7 instead of a 6. I totally wrote the wrong exponent there. Phew. So odd power like a 7 or a 9 is the highest power obtained. Notice we go biggest to smallest power for consistency. And then being bigger than 0, right, that is referring to this is positive. Whereas the other ones, when they're smaller, smaller than 0, you can see that negative sign. There's that negative sign right there. So the end behaviors that we saw were even, right? Positive exponent was up and up. If it was even with a negative exponent in front, it flipped it. And then odd with positive was kind of like this shape. And then odd negative is like this shape. I remember this one of being the norm because it's like right-handed is the norm. So that's kind of how I help myself remember that sometimes. And then this one is getting us used to some vocabulary. So I bet you guys could probably figure out which one is which. You're going to match examples of what functions could look like with the vocab word that you think best describes them. So think about some of those prefixes you've learned before. Okay guys, so these are generally the ones that my students are able to, in years past, match first, right? Linear versus constant versus cubic. Generally, the students have trouble with like what it means to be quadratic versus quartic. Quadratic we know is 2, but the question is G and K both have powers of 2. The idea though is if you were to multiply this stuff out, you would get from the x minus 1 squared, right? You would get an x squared minus 2x plus 1. If you multiplied out the x plus 2 squared, you'd get this. And if you multiplied them both together, right, this is kind of saying multiply them twice, right? You do the first 2 multiplications, then you multiply all that together. It's like a lot of multiplication. Notice you would get x to the 4th. X to the 4th is quartic, whereas our other example is quadratic. So these ideas that we see on this page really are the crux of some of the background for polynomials that we'll need to know before we try and graph them. So in video 2, we're going to use this vocab to do a graph of a function.